And we're continuing solving quadratic equations. This time we're going to do it with the quadratic formula. So a quadratic equation is ax squared plus bx plus c equals 0. Now with some good algebra and some completing the square, the quadratic formula was developed. Solve for x, you get opposite of b plus or minus square root of b squared minus 4ac all over 2 times a. So in this case, a is 2, b is 4, c is negative 12. So to solve this with the quadratic formula, x equals opposite of b plus or minus the square root of b squared, so that's 4 squared, minus 4 times a, which is 2, times c, which is negative 12, all over 2 times a. So we get negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 12, and that's a negative times a negative, so we're going to get a positive. So that's all going to combine to make 112. And 2 times 2 is 4. 112 can be split up into the product of two numbers, one of which is a square number. Negative 4 plus or minus the square root of, and the biggest square number that's going to go into 112 is 16. And it goes in 7 times. So 112 is 16 times 7. The benefit of doing that, now that I've got a square number right here, I can take the square root of 16 to simplify this. I get negative 4 plus or minus, square root of 16 is 4. Square root of 7 is irrational, so we'll just leave it as square root of 7, all over 4. And now I can simplify this because all three terms here are divisible by 4. So negative 4 divided by 4 is negative 1. 4 root 7 divided by 4 is root 7. And 4 divided by 4 is 1. So I could put this whole thing over 1, but that really doesn't mean anything. So my two solutions are x equals negative 1 plus root 7 and negative 1 minus root 7. Here's my a, b, and c. So x equals opposite of 9 plus or minus the square root of 9 squared. I like to put parentheses around this, even though it doesn't really make a difference, because when b is negative, if I don't put parentheses there, maybe when I put it in my calculator I forget parentheses, and it doesn't square the negative, so what's underneath my radical gets messed up on me. So I like to put those parentheses there. So then minus 4 times a times c, all over 2 times a. Nine squared minus 4 times 3 times 9 is all going to combine to make negative 27. And 2 times 3 is 6. 27 is divisible by a square number. 9 goes into 27 3 times, so 9 times 3. But we didn't use that negative, so I'm going to actually split that negative out also into negative 1. 9 times 3 times negative 1 makes negative 27. The square root of 9 is 3. The square root of negative 1 is I. The square root of 3 is irrational, so that's going to stay there. And I can simplify. 3 goes into all three of these terms. Negative 9 divided by 3 is negative 3. 3i root 3 divided by 3 is I root 3. And 6 divided by 3 is 2. I can leave my answer like that, or I can split it up into two separate fractions. Negative 3 over 2 plus or minus I times the square root of 3 over 2. So either way, to together or separate. There's my two solutions. Now if we look back right here and right here, what we got under the radical, a positive number under a radical tells me I'm going to have real number answers. A negative number under the radical tells me I'm going to have imaginary answers. Okay, just a quick note that when I have a positive and a negative between otherwise the same numbers, negative 1 and root 7, I've got a plus and a minus. Negative 3 halves, and then I root 3 over 2, I've got a plus and a minus. That's called conjugates, and that will actually be important in some other lessons we'll do. The discriminant of a quadratic is b squared minus 4ac, which should seem familiar because in the quadratic formula, that's right here, that's what's under the radical. That discriminant tells us what kind of roots we're going to have. Here, we had a positive, and we had two real roots in the end. Those roots are real. Here we had a negative, and we had two imaginary roots in the end. There's my two imaginary roots. If the discriminant is less than 0, which means the discriminant is negative, I'm going to have two imaginary roots. If the discriminant is greater than 0, meaning it's positive, I'm going to have two real roots. But then what if it's just in between? It's neutral. If the discriminant happens to be 0, so we get the square root of 0, then I'm going to have one real, and I'm going to have one imaginary root. Okay, so two imaginary roots might look like this. Doesn't ever touch the x-axis. Two real roots would look like, maybe like that. It touches the x-axis twice. One real and one imaginary means it's going to touch the x-axis one time. So here in A, the discriminant, b squared minus 4ac, is 4 squared minus 4 times 2 times negative 12. These are the same numbers we used above. We ended up with 112. The discriminant is positive, which means I'm going to have two real roots. And in B, same one as above, 9 squared minus 4 times 3 times 9 is negative 27. The discriminant is negative, and that tells me I'm going to have two imaginary roots.